On your screens, you can see a volcano. This is the Haile Gubi volcano. It is a shield volcano that is located in Ethiopia's Afar region, known for its wide, gently sloping structure formed by highly fluid basaltic lava. It has been dormant for the last 12,000 years up until now. Hello and welcome to another episode of Deep Dive brought to you by NewsX. I'm Megha Sharma, and today I will take you through the until now dormant volcano and its massive eruption after thousands of years. This volcano lies within the Afar Depression, one of the most tectonically active rift zones on Earth, where the Nubian and the Somali plates are diverging, creating fissures that allow magma to rise easily, which is why earthquakes are more frequent in this region. The volcano is part of the broader Erta volcanic range, famous for its continuous lava activity and rift-related Ethiopia volcanic eruption. Its geological setting makes it a part of the ongoing rifting process shaping the East African landscape. The Haile Gubi volcano lies within the East African rift system, where the Nubian plate and the Somali plate are gradually separating. This rifting process thins the crust, allowing magma from the mantle plume beneath Afar to rise easily. The Afar Triple Junction, where the Red Sea Rift, Gulf of Aden Rift and East African Rift meet, is what actually makes this region a hotspot for volcanic and seismic activity. The Haile Gubi volcano had no confirmed eruption for nearly 12,000 years, making its 2025 Ethiopia volcano eruption a major geological event. On 23 November 2025, it produced a subplinian eruption characterized by the strong vertical ash column and widespread dispersal. The ash plume traveled across Yemen and Oman before drifting eastward towards India. Satellite images have captured the sudden awakening of Ethiopia's Haile Gubi volcano, which erupted on Sunday. The volcanic eruption sent huge plumes of smoke nearly 14 kilometers into the sky. The eruption lasted several hours. When a volcano erupts, it releases ash, gases and fine particles high into the atmosphere. In the case of the Ethiopian eruption, the ash plume rose to very high altitudes, high enough to reach the jet stream, a fast-moving band of winds in the upper atmosphere. Once volcanic ash reaches these heights, it can travel thousands of kilometers across continents. Ash at flight levels 10 to 12 kilometers is dangerous for aircraft because it can damage engines. Therefore, countries along the ash plume's path issue aviation alerts. Weather impacts are usually small unless the ash is very dense. Once in the jet stream, the ash moved rapidly from Ethiopia post the eruption across the Red Sea and into Yemen and Oman. Due to the particles being so thin, it was able to travel faster and across a wider area. Post moving through the regions of Red Sea and Oman, it then moved towards India, entering through Gujarat and Rajasthan, moving further to Delhi, Uttar Pradesh and northeast India. It managed to enter the Indian space and moved across regions of North India. After entering through these regions and of course coming till the national capital, it then exited India Tuesday night at around 10:30 p.m. and finally drifted towards China. This path follows the natural direction of high-altitude winds. Volcanic ash is extremely fine, like powder, lightweight, easily lifted and carried at high altitudes. Unlike normal dust, volcanic ash can stay suspended in the atmosphere for days or even weeks, making long-distance travel possible. Flight operations have been impacted in India after an ash plume from volcanic eruption in Ethiopia reached Delhi and Maharashtra and other states on Monday. Due to the drifting ash cloud, visibility has dropped in several routes, while Delhi and nearby regions are already struggling due to seasonal poor air quality. Akasa Air announced the cancellation of its flights to and from Jeddah, Kuwait and Abu Dhabi scheduled for November 24th and 25th because of the volcanic ash plume. KLM Royal Dutch Airlines also cancelled its Amsterdam-Delhi flight along with the return Delhi-Amsterdam service. Indigo, SpiceJet and others also informed passengers through social media that they are closely monitoring the situation and advised them to check their flight status regularly. The ash plume mostly consists of sulfur dioxide with low to moderate levels of volcanic ash. The cloud is too thin to worsen the air quality. However, sulfur dioxide levels may show a slight rise, particularly in the Himalayas. A volcanic eruption may be local, but the ash it releases is anything but. Its ability to drift for days or weeks together means its impact stretches far, shutting down flights and affecting lives far away from the volcano. Professor Vibhuti Rai, he is a geologist, joins me on the show right now. Professor, thank you for joining us on NewsX, and I do want to understand from you this phenomenon. After the volcano has erupted, its impact has lasted until 3 days and seen by way of cancellation and diversion of flights in India. It has mostly impacted northern India, but it has moved away from India into China. How long do you think this impact is going to last that has crossed continents?
Well, this is one of the rarest of the events where the Ethiopian volcanic eruption had such a high altitude of flow of toxic gases like sulfur dioxide, methane, and many others, along with the particulate matter of ash, which has gone about 12 kilometers high. And then the jet stream, which is in this season, moves from, let's say, African part to northeastern part, right into China, has pushed the plume of the ash along with the toxic air towards Oman, and then it has moved to western part of India and then northern part of India. Fortunately, yesterday evening by IST 10 o'clock, the IMD, the Indian Meteorological Department, has cleared that the entire this gaseous plume has moved northwards towards China and perhaps would move towards Japan. So presently the impact has reduced, but I must tell you that such volcanic eruptions, they happen in a few hours time, and then maybe they get repeated in the days to come. So for the present, the particulate matter would be there for almost 3-4 days, and that's why the flights have been cancelled by many of the airlines, international travel between Middle East and India, for the simple reason that this ash, when it comes in contact with the engines of the aircraft, it actually heats it up, because ash has a certain component known as silica, and that silica burns up the various parts of the engines, and it has been seen in the past that engines fail. So taking into cognizance this particular issue, whenever there is any kind of volcanic eruption, then most of the airlines, they cancel the operations. Unfortunately, today itself in the Pacific region, there was another earthquake, another volcanic eruption which has taken place, but that most of the part would be over the ocean. So let's say we have to be careful for about a week or so, and then certain parts, if the entire strata of the gas, if it comes down, and if in case there is any rain or the cloud formation, then at times it turns into acid rain. That is very, very harmful for the biosphere. Okay. So let's hope that...
I also want to know from you about how this volcanic eruption has happened in a lifespan of 12,000 years. What may have jolted it to erupt?
Okay. For your viewers, I must clarify in simple terms, there is something called Rift Valley, and the eastern part of Africa has got a Rift Valley. That means the continent is splitting into two parts, which is running almost north-south or almost north-south. So because of that, there is thinning of the upper part of the lithosphere, and this entire Rift Valley has very high thermal regions, and number of volcanoes are already existing all along the Rift Valley, which is almost following the Nile River. In the north of the entire continent, we have the Ethiopia, and that part is called as the Ethiopian Rift Valley. And further north of it, there is a depression which is called Afar. Now, Afar is a very important tectonically sensitive zone, because three rift valleys, they join at a point which is called as triple junction. Now, this particular volcano is very close to the triple junction, and almost 800 kilometers from Addis Ababa in the northern part. And there itself, the crust is still thinner. So, because the tectonic plates are always moving with respect to each other, either they are moving away from each other, then it is called rift. When they are moving towards each other, then there is a compressional zone, and sometimes they move side by side. So earthquake and volcanoes, they happen because of this tectonic activity in the Earth's upper part, which is called lithosphere. So this particular volcanic eruption has happened because of the movement of the tectonic plate in the rift zone. Yes, please.
All right. Thank you, Professor Vibhuti Rai, for joining us and sharing information and insight into this development, this natural development of the eruption of the volcano from Ethiopia that has impact on continents including Asia, and has impacted India and is moving forward towards China. All right. On that note, I slip into a short break. Thanks for watching.